Let's look at a couple of attributes of functions problems. Suppose I have the function f of x is 2x plus 3. Now, the first attribute I want to look at is its domain. For domain, you want to see what can x not equal. So for my domain, there's nothing x can't be. I'm not taking the square root of a negative number. I don't have 1 over 0. So my domain is going to be the set of x such that x is a real number. If I wanted the range, all right, as x gets very large in the negative sense, this is going to go to negative infinity. As x gets very large in the positive sense, it's going to go to positive infinity, and there's no number between there that the range can't be. So the range is a set of y such that y is a real number as well. Now let's look at the intercepts. The intercepts, we put x-intercept here. The x-intercept is where y is 0. So to do this problem, I'm going to put the word x-intercept and then I'm going to put y equals 0 underneath, so I remind myself that's what I'm doing. And then I'm going to go through the mathematics and do it. So 0 is equal to 2x plus 3. Subtract 3 from both sides. So negative 3 is 2x. So divide both sides 3 by 2. So x is minus 3 halves. So to graph this, you're going to graph the point. I'll put my x-intercept here. Negative 3 halves, 0. So I'm going to come over here. This is negative 1, negative 3 halves, 0. The y-intercept is where x is 0. So everywhere in here I have an x. I'm going to put in a 0. So y is 2 times 0 plus 3, which is 0 plus 3, or just 3. So the point I'm going to graph is x is 0, y is 3. So x is 0, 1. This is kind of hard to see on here. 2, 3. All right. So to put in my line, I'm going to use my tool function here to make my line a little bit easier. I'm going to put in a line that starts here and goes down. Is it showing up? Doesn't want to show up. That's right, there we go. Now I'm going to extend my line back in either direction. All right. This particular function has no asymptotes. But I do want to talk about the maxes and mins. It is possible to talk about, while there is no max or min of the function itself, it's possible to talk about the maxes and mins on a closed interval. So suppose I look at the interval negative 2, 2, 2. All right? So it's this interval right here, negative 2 to 2. I can see I'm going to have a minimum value and a maximum value, or where the function is smaller than all of the other values of the function on that closed interval. So my minimum, I can tell from my graph, is going to occur at x equals negative 2. Now, a minimum is a y value, so we need to evaluate this. F, evaluated at negative 2, is 2 times negative 2 plus 3, which is negative 4 plus 3, or negative 1. So the minimum is negative 2, negative 1. While the maximum on this interval is this point up here. So I need to find out what it is. It is going to be f evaluated at positive 2, which is 2 times 2 plus 3, 4 plus 3, or 7. So the maximum occurs at 2, 7. The maximum value is 7. The minimum value is -1 on this closed interval. Sometimes you're going to have real-world problems, like this one, where you have a store selling cube-shaped storage containers, and the cubic function is f of x is x cubed. Gives the volume in cubic inches of a container with edge length of x inches. Now, for this one, our domain is, you can have, it's going to be the positive x's. X has to be positive. Can you have an actual cube that has dimensions 0, 0, 0? I'm not going to argue the point, but I'm going to say no. So I'm going to say that the domain is from 0 to, now realistically we can go to infinity because x can get incredibly large. The range, now if I'm not including 0 for the domain, I can't include it for the range either. So there are those who would argue you could include 0. Personally, I prefer not to. Now, what kind of intercepts do we have? In this case, because we're not including 0, 0, this one has no intercepts. The cubic function also has no asymptotes because it's going to shoot off towards infinity. So I'm going to see, what does this look like? At 1, it's 1. At 2, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. Is that about right? So this function is going to look something like this. With no asymptotes. I could find maxes and mins. If I wanted the maximum on, say, what? 1, 2. The maximum is going to occur when x is equal to 2, because this is an increasing function. So f of 2 is 2 cubed, or 8. So the maximum on this closed interval is 2, 8, while the minimum on this interval is going to occur when x is 1. So f evaluated at 1 is 1 cubed, or 1. So the minimum is going to be at 1, 1. Now, let's look at the function f of x is 1 over x. Now, our domain here is going to be the set of x such that x cannot equal 0, because we cannot divide by 0. Our range, as it turns out, is going to be the set of y such that y does not equal 0 as well. We're going to show that here with the graph in a second. Since x can't equal 0 and y can't equal 0, it has no intercepts. Let's make a table. At x equals 0, this function is undefined. So I'm going to put the undefined point in the middle. And now I'm going to move in the positive direction. Let me start with the point 0.1. 1 over 0.1 is 10. let me go to the next point is 1. 1 over 1 is just 1. 5. 1 over 5 is 0.2. And then let me do 10 out here. 1 over 10 is 0.1. So if I graph these points, at 0.1, it's up here at 10. So that's, goodness gracious, that's way up here. I'm going to put that point right up there, approximate it. At 1, it's 1. At 5, it's 0.2. 2, 3, 1, 2, 3, 4, 5. So this is getting, oh, you can tell this is getting really close to this x-axis. All right, let's see if I can do a nice smooth curve here. This is, well, not really, but you get the idea. I see that as x gets closer and closer to 0, it's going to shoot off toward positive infinity. And as x gets larger, then the y values get closer and closer to 0. So we can say I have a horizontal asymptote of, remember the horizontal asymptotes are y equals, so this is y equals 0. And I have a vertical asymptote of x equal to 0. And I was able to pull all of that off this first branch. Now suppose I go backwards. It turns out this is symmetrical. So if I go to negative 0.1, this is going to become negative 10. At negative 1, it's negative 1. At negative 5, it's negative 0.2. And at negative 10, it's negative 0.1. So when I graph those points, at negative 1, 10th, it's negative 10. So that's going to be way down here. At negative 1, it's negative 1. At negative 5, it's 1, 2, 3, 4, 5. Okay, so you get the idea. This curve is going to have, whoa, that's not very good, but you get the idea. It's going to have the same asymptotes. As I approach 0 from the left, it's going to become unbounded in the negative direction. And then as my x values become more negative, it's going to approach this y equals 0. So my asymptotes don't change. I would like to write the domain and the range in a different format for you. Another way you can write this domain is in negative infinity to 0. You might see it this way as well, and the range is the same. We have to throw this 0 out.